Go.
Hello everyone again. I'm pleased to introduce Rafael Amaya. Rafael was raised in Bogota, Colombia. He's a graduate of University of Los Andes in chemical engineering, and he earned a master's degree in chemical engineering also. And his main area of research is reliability and risk analysis in hydrocarbon pipelines. And his work is directed mainly towards to support decision-making process regarding pipeline integrity and future interventions planning. His work includes stochastic modeling and optimization to evaluate a degradation mechanism due to corrosion. His work includes within the hours earned by Rafael, it includes an honor mention in the 5th best postgraduate thesis in chemical engineering by the Chemical Engineering Professional Council, and the Andean Pacific Regional Award of Innovation in Hydrocarbon Transportation Logistics by Ecopetrol. Additionally, he was being a teacher assistant in the departments of Chemical Engineering and Mathematics for about 4 years. Currently, he is doing a PhD from Doctoral School of Engineering, and he is finishing his mathematics degree, both at Los Andes University. So, welcome, Rafael.
Thank you, Camilo. So let me show you this picture. I want you to just take a look and we just get what happened. This was a real event that happened in Guadalajara, Mexico in 1992. It was an explosion. What happened is that the city installed new water pipes or sewers that were built too close to a gasoline pipeline. So what happened? The sewer has a new shape because the subway city was expanding, and it was like in this shape because the subway has to pass through the pipeline, and because of the proximity of these two pipelines, it provokes a chemical reaction that provokes a failure, corrosion, and the gasoline gets into the sewers. So what happened is that the gas accumulates in this area and provokes an explosion. Indeed, it was not only an explosion, but a series of 10 explosions in the downtown of Guadalajara that provoked over 200 deaths, about 500 to 600 missing people, nearly 500 injured people, more than 50,000 homeless, and over 300 million in economic losses. However, this is not an isolated case. You can be seen in a lot of sites in Latin America, for example, in Dos Quebradas, Colombia in 2011, but also in the United States. What I want to show you is that these failures are occurred mainly by 5 causes that are natural forces, for instance, earthquakes or landslides, operational failures, third-party mechanical failures, and the one I am working on is in the corrosion. So, are you sure about the safety of a hydrocarbon pipeline, where in this case I mean hydrocarbon of oil, gasoline, natural gas, and related compounds? So, I will show you a technique that I use to prevent these events. Let me show you first what is a non-destructive technique. It's a wide group of analysis without causing damages on the component. Probably this too was totally destructive technique wherein you at home, but overall are techniques to evaluate the properties of the material, and some applications are for failure prevention, system design, and maintenance planning. So let me talk about what is a pigging. And I'm not really mentioning about Miss Piggy, but a pipeline inspection gauge, that is this device. This device is introduced in the pipeline in a section or the entire pipeline in order to clean, in order to inspect, or to map the pipeline route. This later is very important because of earthquakes or landslides, the pipeline may move a couple of meters, and because of this, the stress also could be a cause of a failure. So, if I focus on inspections, there are 3 main issues that are material loss of the steels that are related to corrosion defects, geometric failures, and crack detection. So let me give you some analogies of what is a pipeline inspection gauge. instead of cholesterol and arteries that are cleaning your arteries and make you an endoscopy. Okay? So it's like a device that let you make these two things. So let me give you a broad definition of what is an inline inspection. Inline inspection is non-destructive techniques that provides detailed information regarding the inner and the outer condition of the pipeline using an pipeline inspection gauge, as in this case. One of the most important things is that ILI is the only inspection that offers a total coverage of the pipeline. What I mean is that it's not only along the pipeline, but also determine the orientation or the direction in which the defects are located, as in this case. So, what I mean is that ILI inspection can be used to evaluate corrosion evolution if a set of these are used. So let me give you a broad overview of what techniques are used in the corrosion assessments or the material loss assessment that is based on a magnetic flux. The device is introduced in the pipeline and creates a magnetic flux. When a defect is obtained, this is a leakage or a spread out of this flux, and based on a hardware records this location of the defects. Another approach is using an ultrasonic technique based on a set of sensors that provokes a signal, and based on an analogy of a mirror, based on the rebound of this signal, determine if it's an inner or an outer defect. So let's wrap up what I'm saying. Is inline inspection are not destructive techniques. It offers a total coverage of the pipeline, and they use pipeline inspection gauge to clean the pipeline, to determine the pipeline condition, to map the pipeline route. And for corrosion, evaluation is implemented, such as magnetic flux and ultrasonic. So, why is this important for my research? I work in process safety and risk analysis, so we aim to, based on a set of ILI inspections, to propose degradation models that are regarding the corrosion evolution, to maintenance policies, that is when and where this maintenance should be done, and the failure probability assessment in order to prevent events as the one I showed you in the Guadalajara in 1992. Thank you very much.
So this pig does also clean the pipeline from inside?
There are very different types, and one of those is type. Indeed, here you can see some brushes that are you are inspecting, and also you are cleaning the pipeline.
Cool.
You install it.